Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Hope today I'll recover from yesterday's just tiredness. So I am doing this live, so sometimes I don't get it all like immediately all the time, as opposed to explanation video. I always find that the learning is in how you mess up. Sometimes it's important to learn from how you don't get it right, but well, we'll talk about that later. Hopefully, we'll see how this goes. Anyway, today's problem is buddy string. Given two strings A and B of lowercase letters, return true if you swap two letters in A so that results in B, otherwise run false. Okay. So it's almost like, I think this is straightforward because there could only be two, right? So you need two things that are out of place. Maybe. I think I have to think about all this for a little bit, because I think so. The one thing that maybe the only case that I have to kind of consider a little bit better, because okay, so I think if you have only two characters out of place, then it's straightforward, and that's straightforward to implement. I think the case that I have to kind of prove to myself is something like this. Now I guess it's still two characters out of place, right? So that should be straightforward. Yeah. Okay, so then I think that should be okay. Yeah, okay. Let's just implement it, right? If we have two characters out of place, then it's good. So for let's see. Let's just do xy in sip of ab. If x is not equal to y, let's just have a list of incorrect things. Incorrect is equal to a list of array. Then we just incorrect dot append. Let's just do a xy, and then one is if we have more than two, then that's already wrong, right? So if length of incorrect is not 2, then return false. Because even if you have one out of place, what is it to mean to have only one out of place, right? It means that, or if they not match, it means that there's one that doesn't match, right? So we need two, and they need to be kind of, togetherness. I think there may be another tricky case where, okay, so you have to swap them. So yeah, so length has to be equal to 2. So I was worried about this one here. But there may be another case where, okay, actually they give you a lot of cases. I was just thinking about these without really looking at the test cases. But I think those are the only ones where this one, in theory, there's 0 numbers out of place, but there are ways to kind of swap two numbers where you could swap it to each other. So we might have to kind of play around with that idea. But, yeah, so I think those are all the cases. They tell you all the test cases, which is very polite of them, very kind of them. And I think this is the other one, is that if incorrect of 0 is equal to incorrect of 1 and this, basically we're just in a brute force way writing, that's true. Otherwise this is just false, right? Because then that means that they have different things. So we can actually just return this. Okay, but as we said, we have to add some conditionals either before or during this, where if it's someone like this or even someone like this, then then we should be able to swap two characters that way. And the only case that this could be true is if well, first of all, the length has to be the length of the incorrect, which means that there has to be two no things out of place. And then if any of the characters appear more than once, then that's all you need. And I'm kind of lazy, but okay, fine. I guess we could put it in this as well, which is that C is equal to collections.counter. And I know that you could do it in a, you could put A in here, for example. But I just want to put it in the same loop, which is that C of X plus equal to 1, right? and we only have to care about the strings in A for, so if this is 0 and any of so basically if any value of this is greater than 1, then we're good, because then you just swap it with each other, right? Okay, so then we could express it that way with a c dot values. So x for x is greater than 1. Oh, man, this is not syntax. Sorry. For if x is greater than 1, then this is true. Okay. Let's just run it real quick for the syntax. I have a typo on my syntax. Oh, oops. And then now let's go for all the cases. There's a lot to type here, so bear with me. You could also copy and paste, but I'm not sure that copy and paste is any faster at this point. Except for maybe for longer ones. And the other ones just... They really gave you all the edge cases. I was actually going to go for without looking at mostly because usually I don't look at the examples if I understand it quickly, just because I'm already doing it. But it seems like it matches these cases at least. Let me think for a quick second what other cases there could be. I guess the 1 index, like do, and then just 0 index matching, and maybe just 1 index where it's wrong, or not wrong, it's different. It looks to be okay, so let's give it a submit. Fingers crossed. Cool. So what is the complexity of this? Well, we look at each character at least at most once, so that's going to be all 1. I actually could optimize this a little bit if you pay attention, which is that technically I use O of n space here, but you really only have to keep track. But depending on how you want to count it, because this is only going to have at most 26 characters. You could have done it another way, but this is going to be at most 26 characters, which are the number of lowercase characters. So that's going to be O of 1 space, if you want to count it that way. Incorrect can actually be O of n in linear space, but if you just add something like n incorrect is less than 3 or something like that, right? Because all you care about is that it is exactly 2. So if it's 3 or more, then you can append it, right? So that it becomes 3, which is then you don't care about it. And in this case, you can show that incorrect is also all 1 space, because at most it has 6. Oh, sorry, it has 3 elements of 2 elements each, so it's just 6 elements. So yeah, so this is, so you can, what I'm saying is that you can solve this in all of 1 space, and it's gonna be linear time because we look at each character at most once here. We look at another linear time here, and everything else is all 1, right? So linear time, constant space, and that is the problem. I'm glad I actually solved one quicker than yesterday. Let me know what you think about this one. It's a little bit easier than yesterday's, but yeah, hit the like button, hit the subscribe button, join me in Discord, let me know how you feel. And I will see y'all tomorrow. Bye bye.